Hello, this is Mason Haggerty with question 10.7 from the Fundamentals of Heat and Mass Transfer by Bergman. This question states, the hysteresis behavior of the boiling curves becomes less pronounced as the difference between the minimum and maximum critical heat fluxes becomes small. Calculate the ratio of the maximum to minimum boiling heat fluxes for water, ethanol, refrigerant R134A, and refrigerant R22. Which fluid has the greatest potential for the most severe hysteresis effect? For which fluid is the critical heat flux largest, and what is its value? The boiling occurs at atmospheric pressure on a large horizontal surface. So to begin, we're just going to quickly assume here that G equals 9.81 meters per second squared. And I've also pulled out a screenshot of table A5, which has properties for all of the required materials besides H2O. So here you can see I've highlighted ethanol, refrigerant R134A, and R22. And right below it here, I have written in H2O, which comes from a different table. So this is all of the properties that we will need. So we know from the book, equation 10.6, that the maximum or critical heat flux is equal to C times HFG times the density of vapor times sigma G times density of liquid minus density of vapor over the density of vapor squared, all to the 1/4. And for large horizontal plates, C is equal to 0.149. Along with this, in equation 10.7, we know that the minimum heat flux is equal to C times the density of vapor times HFG times G sigma times density of liquid minus density of vapor over density of liquid plus density of vapor squared, all to the 1/4. And for this case, again with large horizontal plates, again from the book, C is equal to 0.09. So with that, we can get into it. So we know that for water, the critical heat flux is equal to 0.149. Again, that's the C given in the book. 2,257 kilojoules per kilogram. That's the HFG that we found in the tables. 0.596 kilogram per cubic meter is the density of the vapor that we found in the book. And we then have multiply that by 58.9 times 10 to the negative 3, which is the sigma for water, again from the book, times 9.81, that's gravity, times 958 minus 0.596 kilogram per cubic meter, that is the density of the fluid minus the density of the vapor, all over 0.596 kilogram per cubic meter squared, which is the density of the vapor squared. And then you put all that to the power of 1/4, and you get a Q max of 1,259 kilowatt per meter squared. So for the Q min, you have 0.09 multiplied by 0.596 kilogram per cubic meter times 2,257 kilojoules per kilogram multiplied by 9.81 meters per second squared times 58.9 times 10 to the negative 3 Newton per meter times 958 minus 0.596 kilogram per cubic meter all over 958 plus 0.596 kilogram per cubic meter squared, all to the 1/4, which gets you a Q min of 18.96 kilowatts per square meter. Next, on to ethanol. Our Q max is equal to 0.149 times 846 times 1.44 times 17.7 times 10 to the negative 3 times 9.81 times 757 minus 1.44 all over 1.44 squared, all to the 1/4. Obviously, I've left off units, but they're the exact same as for water, so you can check through there. And this gets you 511.9 kilowatt per square meter. Next up for the Q min for ethanol, it is 0.09 multiplied by 846 times 1.44 times 17.7 times 10 to the negative 3 times 9.81 times 757 minus 1.44 all over 757 plus 1.44 squared, all to the 1/4, which equals 13.47 kilowatts per square meter. And for R134A, you get a Q max of 281.4 kilowatt per square meter and a Q min of 10.48 kilowatt per square meter. And for R22, you get a Q max of 300.4 kilowatt per square meter and a Q min of 10.46 kilowatts per square meter. So pretty similar to the R134A. So now let's look at the hysteresis effect. So that again, in the question, it lets us know that it is the
becomes less pronounced as the difference between the minimum and maximum heat fluxes becomes small. So it wants to calculate the ratio of the maximum to minimum boiling heat fluxes. Therefore, we're just going to put the Qmax over the Qmin for each of these cases. So for water, Qmax over Qmin, which is again equal to 1,259 kilowatt per square meter divided by 18.96 kilowatts per square meter, you get 66.4. For ethanol, you're going to get 37.99. For R134A, you get 26.84. And for R22, you get 28.72. So from this, we can see that the least likely, or the least pronounced difference would be between R134A, meaning it'll have the smallest amount of hysteresis effect. In contrast, water at 66.4 has the highest potential for a severe hysteresis effect. It also has the largest critical heat flux, which is another part of the question. With that answers everything that the question wanted. The answer for both is water, with a ratio of 66.4 and a maximum heat flux